Today's lesson is 12-5 and 12-6. Our objectives are to add rational expressions with like denominators, subtract rational expressions with like denominators, and divide a polynomial by a monomial. We're actually going to start with that last objective right there. We want to learn how to divide a polynomial by a monomial. We've learned how to divide two different rational expressions, but we want to learn how to multiply one monomial by or polynomial by one monomial. Alright, here's number 1. Go ahead and write it down. We have 18n squared minus n divided by 9n. We have a binomial divided by a monomial. So we're actually going to write this a little bit different. We're going to write it as a big fraction. We're going to say 18n squared minus, and I'm going to say 1n, all divided by 9n. Now, anytime you have a polynomial, meaning more than one term, divided by a monomial, which is just 1, you're actually going to split this up and divide each thing in your numerator by your monomial in your denominator. So we're going to split this up and say 18n squared divided by 9n minus 1n over 9n. Now I just need to see if I can reduce these fractions that I've made. So in my calculator, I'm going to do 18 over 9. So I'm going to hit my alpha y equals to get my fraction and say 18 over 9, just the way I have here. And I get 2, or 2 over 1. So I am going to end up with 2 over 1. Now I need to look at the n's. On the top, if I have n squared, that means n times n. So I can write that as n times n. So here, one of the n's on the top and one of the n's on the bottom are going to cancel, and I'm left with one n that's still left on the top. I can also do that using my exponent properties and say 2 minus 1 is 1, because if I'm dividing with my exponent properties and my base is the same, I can subtract. So over here, I have 1 over 9 which even if I put it in my alpha y equals of my calculator, 1 over 9 does not reduce, it stays 1 over 9. And my n's here, I have 1 on the top and 1 on the bottom, and they're going to cancel. So this is what I have left. I'm going to write this a little bit differently because anytime we have a 1 on the bottom, we don't need it. So I'm going to say 2n minus, and this has got to stay 1 over 9 because, again, if the 1's on the numerator, I still need it. So that's my final answer, 2n minus 1 over 9. Please make sure you have all that written down before you move on. All right, go ahead and write down number 2. We have 8p to the third minus 4p squared plus 12p divided by negative 4p squared. So again, just like I did before, I'm going to rewrite this as a fraction. And then again, like I said, anytime you have a monomial on the bottom, since I can't factor that, it's just a monomial by itself, I'm going to take and divide each individual thing by that. So we're going to say 8p to the third divided by negative 4p squared minus 4p squared divided by negative 4p squared plus 12p divided by negative 4p squared. And here I'm actually going to change this to plus a negative, just because that's going to make it look a little bit better. All right, now we're going to start reducing. So I'm going to look at that first one. I've got 8 divided by negative 4, so I'm going to do my alpha y equals 8 over negative 4, and that gives me negative 2, or negative 2 over 1. And then I have p to the third over p squared. So again, you can either look at this and subtract 3 minus 2 and get 1, or you can write them out. P to the third is 3 p's. P squared is 2. And you can start canceling. These two are going to cancel, and these two are going to cancel. And I'm going to be left with that 1 there on the top. So I'm going to say plus. I'm going to go to the second one and hit my alpha y equals, and I'm going to say negative 4 over negative 4. and I get 1, or 1 over 1. And here we can either say 2 minus 2 is 0, and anything to the 0 is just 1. Or we can write out our 2p's for p squared on the top, and our 2p's for p squared on the bottom, and cancel them out. And when I cancel them out, I don't have any p's left at all, so I just have a 1 over 1 here. And I'm going to say plus. I'm going to hit alpha y equals and do 12 over negative 4. That gives me negative 3. Or negative 3 over 1. Then here I have 1p on the top and p squared on the bottom, so I can again write that out as p times p. This one and this one cancel, and this time I have a p left, but it's on the bottom. So it's going to go right there. Then I'm going to clean this up just a little bit. I'm going to say negative 2 over 1. If the 1's on the bottom, I don't need it. So it's just negative 2p plus 1. And then we're going to say minus. And then here it's going to be 3 over, and I don't need that 1 in front of the p, it's just going to be 3 over p. And that's as far as I can go with that. So that is my final answer. Please make sure you have all of that written before you move on. All right, now we're going to go on to another objective. Our objective now is to add rational expressions with like denominators. So here we have 3x over 2x to the fourth plus 5x over 2x to the fourth. Again, we have like denominators because anytime we're adding fractions, we have to have like denominators in order to add, or we have to make them like denominators. So here, all we're really going to do is I'm going to start by bringing over my common denominator. And so the same on the top and bottom, all I do is bring over the denominator. Now in the numerator, I'm going to add up all of my like terms. Since the 3 has an x and the 5 has an x, I can add those. And I get 8x. And now I just need to see if I can reduce this. So I'm going to do 8 over 2. Oops, wrong button. So 8 over 2. I get 4, or 4 over 1. And then again, I'm going to do the same thing here with my x's. I have 1x on the top and 4 on the bottom. So if I want to rewrite this instead of x to the fourth as 4x's, I can do that. And then notice the 1 on the top is going to cancel with one of the ones on the bottom. That's all that's going to cancel. So now I have 3 left, and they're all on the bottom. So this is going to become x to the third. I'm going to make this look a little bit nicer and say 4 over x to the third, because I don't actually need the 1 in front of the x to the third. Okay, that's all the work for that one. Please make sure you have all of it down before you move on. Okay, go ahead and write down number 4. We have m squared plus 2m plus 3 over m plus 4 plus 3m plus 1 over m plus 4. Again, we're adding these rational expressions or fractions, and we have common denominators. Both of the denominators are m plus 4, so I'm going to bring over my common denominator first. And then in the numerator, I'm going to add up anything that's alike. So here I have m squared, and if I look through here, I don't have any other m squared, so I'm just going to bring over my m squared. I have a 2m, and I have a 3m, so I can put those together since they're both m's. 2 plus 3 gives me 5, so plus 5m. And then I can put together the 3 and the 1 because they're just numbers without a variable with them. So I'm going to say 3 plus 1 is 4. So now add, I have m squared plus 3m plus 4 all over m plus 4. Now I need to look at it and see if I can simplify it. Okay, and since I have a trinomial on the top and a binomial on the bottom, I'm going to have to see if I can factor anything. And I'm going to be able to factor this numerator. Now we can't work with it the same way we worked with the first 2 examples because it's not a monomial in the bottom, it's a binomial, meaning 2 terms. So we're going to see if we can factor this numerator and see if anything will cancel with our m plus 4. Okay, so over here I'm going to say m squared plus 5m plus 4. This is a trinomial, so at first I look for a GCF and there's not one. I'm going to put a 1 in front of my m squared, and then I'm going to multiply my first and last. 1 times 4 is 4. It's a positive 4, so I only need one column. So my factors are 1 and 4 and 2 and 2. I'm looking to see which one will add to 5. That would be my 1 and my 4. So I'm going to split 5m up into 1m and 4m. Bring down my plus 4, bring down my 1m squared. And then I'm going to factor by grouping. Here I have a 1m that I can take out, and I'm left with m plus 1. Look at the last two. 4 and 4 have a 4 in common. So I'm going to take out a positive 4. And that's going to leave me with 1m or m plus 1. Because I'm going to say 4 divided by 4 is 1. Bring down my m. 4 divided by 4 is 1. And here, same thing. I had a 1 divided by 1 is 1. You can put 1s in front of those. And then I had 2 m's. I took one out, so I had 1 left. Here I had an m, but I took it out, so I don't have any m's left. Again, what's in parentheses has to match. And it does. So I have m plus 4 from the outside of my parentheses and m plus 1 from the inside of my parentheses. So I'm going to go back up here to the top, and instead of m squared plus 3m plus 4, I'm going to put m plus 4 and m plus 1. All over my common denominator. Then I'm going to look to say, okay, is there anything here that I can cancel like I did in 12-3? And there is. My m plus 4s, I have the same on the top and the bottom, so they're going to cancel. I'm just going to be left with m plus 1 is my final answer here. Please make sure you have everything written for that before you move on.
All right, go ahead and get down number 5. It says subtract and simplify your answer. Our first fraction in number 5 is 6y plus 6 over y squared plus 4y minus 12 minus the second fraction, which is y plus 4 over y plus 4y minus 12. You can see here that they have common denominators, which means that we're able to just combine our numerators. The only issue here, the only thing that's different, is that this is a subtraction problem. So because this is a subtraction problem, we have to consider how that subtraction sign affects the second fraction. So what you're going to do when you see a subtraction sign in the middle, you're simply going to change it to a plus sign. And then you're going to change the sign of everything in the numerator of the second fraction. So you're going to change the sign of everything in the numerator of the fraction that follows the minus sign. Just like I did. So it now becomes plus negative y minus 4, or plus a negative 4. So now we're able to combine our like terms. And it would appear that I made an error in copying and that this should have been a negative 6, I believe, to begin with. Sorry about that. I couldn't see it on the printout. That should have been a negative 6 to begin with, so go back and make that a negative 6 here. Alright, so when I add these, and that's what I've been doing all along, so this is no different than what you just did in the last examples, I'm just going to combine my like terms on the top. So I have a 6y minus 1y. 6 minus 1 is 5y. And I have a negative 6 plus a negative 4, which is going to give me a negative 10. So on the top I have 5y minus 10, and on the bottom I'm just going to bring over what I had, which is y plus 4y minus 12, because it is the same. Alright, so I'm not quite done yet. Now I have to go ahead and factor the top and the bottom and simplify. So I'm going to look here at my numerator, and I see 5y minus 10. My GCF between 5 and 10 is going to be 5. So I'm going to go ahead and factor out a 5 here. So we're going to say 5, and then in parentheses I'm going to have my y minus negative 10 divided by 5 is 2. And then on the bottom I have my y plus 4y plus minus 12. So I'm going to multiply my first and my last terms, which is going to give me negative 12. I'm going to list my terms, my factors of negative 12, which are going to be 1 and 12, 2 and 6, and 3 and 4. And then I'm going to consider the fact that it's going to multiply to give me a negative 12, but add to give me a positive 4, so that means that my lower terms are going to be the negative ones here. Which ones of these will add to give us positive 4? It's going to be negative 2 plus 6. So I'm going to break my 4y down into negative 2 plus 6y. Bring down my negative 12 and bring down my y. So in my first group, I'm going to factor out between 1y and negative 2y. I'm just going to factor out a y. I'm going to bring this over here, sorry. I'm going to say, I'll rewrite that for you, 1y minus 2y plus 6y minus 12. So my first group, again, I'm going to factor out a y, which is just going to give me 1 minus 2. And in my second group, my GCF between 6 and negative 12 is going to be 6. So I'm going to say plus 6. And that's going to leave me with y minus 2. That didn't work out. This y was squared. That y was squared. So that means that was a y there, because that was a y squared. So I only took out one of the y's, so I still had a y left. Good for you, those of you who caught that error before I did. I'm sure there were some of you who did. Y minus 2, and then y plus 6. So that's what's going to go in my denominator now. I have y minus 2 and y plus 6. My y minus 2's will cancel, and I'm left with 5 over y plus 6. And that is my final answer. So make sure that you have all of that down before you move on. All right, go ahead and get down number 6. Number 6 says a plus 8 over 4a squared minus 49 minus negative a plus 1 over 4a squared minus 49. So again, my denominators are the same. All I have to do is change my subtraction sign to an addition sign and change everything in the numerator of the second problem. So let's go ahead and do that. We're going to make this a plus sign. This becomes a plus. This becomes a negative. So now I'm ready to just go ahead and add across. I'm going to go ahead and put 1s in front of my a's here because I like to remember that I'm working with an understood 1. So 1 plus 1 is 2. A, and then 8 minus 1 is going to give me 7. Over, again, it's 4a squared minus 49. My denominator just comes straight across. So now I'm ready to factor. I'm going to look at 2 and 7 and realize that they do not have any common factors. They are both prime numbers. So my numerator is going to actually stay the same. So that's going to be 2a plus 7. It's not going to change. My denominator, however, I'm going to look at this and see that 4a squared is a perfect square and 49 is a perfect square. So I'm going to be able to factor this out as perfect squares. 4a squared is the product of 2a times 2a, and 49 is 7 times 7. So I'm going to write that as 2a plus 7 and 2a minus 7. I'm going to bring that up and put that in my denominator because that is the denominator of the problem that is fully factored. Then I'm going to look here and see that my 2a plus 7 and my 2a plus 7 actually cancel, which is going to leave me with 1 over 2a minus 7 as my final answer. So make sure that you have all of that down. You can pause the video if you need more time. All right, go ahead and get down number 7. It's 4n squared over 4n minus 3 minus 3n over 4n minus 3. So again, my denominator is the same. I have a minus sign in the middle, so that just tells me that I have to change it to a plus sign and then subtract, change the sign of everything in the numerator of the second problem, which is just my 3n. So here, I'm going to go ahead and combine 4n squared minus 3n. Those are not like terms, So I'm simply going to write that as 4n squared minus 3n. There's nothing else I can do. I cannot add or subtract when my terms are not alike, and because of the squared on the end, they are not like terms. I'm going to go ahead and bring over my denominator, which is 4n minus 3, and then I'm going to look at factoring. I do have a GCF here between 4n squared and negative 3n, and that is an n, so I'm going to go ahead and pull that out. That's going to leave me with 4n minus 3. Bring over my denominator, which is 4n minus 3. And then I can see that these actually match. They cancel, which leaves me with an answer of n. You could also write it as n over 1, but n over 1 is simply n. So that's my final answer. Make sure that you have that down before you move on. All right, this is your last example. This is the end of your video. Thank you for watching.